No, Nitin, it's just that I just have to go through the notes. I didn't get a
Yeah.
chance yesterday.
Okay. Because we have covered a lot of Java. I mean, 80% Java is completed. So, I mean, the day we started with the strings and arrays, right? So from that day, kind of advanced Java just started, right? So I'm just little worried about like are you all on track? Because once you start with Selenium, then this Java will be you will have to recall everything again and again. So that is the reason. Please practice. Yeah. So we will cover what is abstraction, how it is achieved, and why it is required. And we will talk about abstract classes, then abstract methods. Then we will talk about what is interface, and again how it is as in how it is implemented and why it is required. Then we will talk about how multiple inheritance is achieved using interfaces. Is achieved using interfaces, and then finally the difference between these two. Okay. So this all we will cover in abstraction. So the first thing here is what is abstraction actually. So uh, abstraction as in we are hiding something, right, from user. So that's the English meaning of abstraction. So how that is actually useful in programming? Any idea? Any of you any of you having any idea about how it is useful in programming? How the abstraction is actually implemented here?
No, Nitin.
Okay. Disha, any idea? You must be having, right? You have I mean in your
Yeah,
past.
but I'm not able, not clear about the
Okay, no
concepts.
problem.
Yeah.
Satara, any idea you have?
No, Nitin.
All right. So what happens, guys, in a class, right? We do have lot of data, right? Data could be in the form of variable or methods, right? We have multiple variables, multiple methods in a class, right? And then we are creating the object of the class. Let's say for a person class, I am creating 100 objects. Or for an animal class, I am creating 100 objects. Or for any sort of class, I am creating a lot of objects. So all the methods or variables will be accessible for all the objects, right? So you're getting this point, right? So all the methods and variables are accessible to all the objects. So let's say I am having 100 objects and 100 methods in a class. So all 100 methods will be accessible by all 100 objects. Okay, now what happens is like one of the object does not need all of the methods. He needs only couple of the methods. He needs, let's say, only one or two of the methods out of 100 methods I have. The other object is having requirement of having only one or two other methods. Likewise, so why to give the access of all the methods to all the objects? It is not advisable as well as it is not necessary. So what we do, we write methods in the form of abstract form in the abstract class, and whichever method, whichever object is looking for implementing those methods, they can implement in their own way, and then they can finally use that. So with this, we are actually achieving abstraction, as well as we are giving only the required functionality to objects. It's not like we are giving all the functionality to all the objects. Is it making sense how why it is required, and what is the need of abstraction? We will see that in example also. I don't know if you are able to understand this definition. So basically definition is we are giving only the required functionality to the user. We are not giving the entire functionality to the user. Okay, so how we will just give me a minute. We will just look into the example. Then how it is achieved. So for achieving abstraction, we use abstract classes. Okay, so we have a concept of abstract class here, and then we have a normal Java class, right? Normal class which we have used so far, and then we have interface. Okay, now we have two types of method here. One is concrete method and other is abstract method. Okay, concrete method is something which is having method header as well as method body. So that's a complete method. We call it as complete method also. So this method is having method header as well as method body. Method header is nothing but the name of the method along with the access specifier, return type, etc. And then followed by curly braces and then method body. So these are called concrete method in programming, and these are also called complete method. Abstract method are nothing but we are just having the method prototype, as in just the method header, and there is no method body. Okay, and those are called incomplete method. Okay, now when we talk about abstract classes, so abstract classes should have one or more abstract method. If any class, a Java class is having one or more abstract method, then that class will become an abstract class. Normal class will have all the methods as complete. All methods are complete methods only. There are no abstract method in the normal class. If there is an abstract method in the normal class, that class will become an abstract class. An interface is having all method as abstract method. So with the help of abstract class, we achieve partial abstraction. Because some of the methods are concrete here, some of the methods are abstract here. So we achieve partial abstraction. And with the help of interfaces, we achieve 100% abstraction. Making sense? What is concrete method and what is abstract method, and what is the difference between these three terminologies? What is abstract class, normal class, and interfaces? Now we talked about how.
Nitin, just one question. So abstract class can have should have one or more abstract method, and can it have other normal method as well?
Yeah, definitely. If there are only abstract methods, then it will become interface. Okay. So along with that, it should have concrete method also.
Okay.
If there are only abstract methods, then it will become interface.
Okay, and that concrete method will be accessible to every other objects.
Yeah, it will be. Yeah, it is an abstract class, so it will be accessible. We'll just check that. Sarah, yeah. So abstract method should be having one or more abstract method plus concrete methods. Normal class having all the methods are complete methods, and interfaces will have all methods at abstract methods. Now we talked about how abstraction is useful in real example, right? So let's say I am having class here. So that class name is basics, and in that I am having one method called, let's say, public void calculate method is there, right? What it is doing, it is taking the input of double, and then it is calculating the square of this. So how do I get that? The square of x is x into x, right? And now what I'm doing, I'm creating three objects of this class. Demo obj1 equal to new demo obj2 equal to new demo obj3 equal to new demo, and okay, so now with the help of obj1 I can access calculate, right? And when I pass something, let's say 3 here, with the help of obj2 also I can access calculate. Let's say I'm passing 4 here, with the help of obj3 also I can access calculate. Let's say I'm passing 5 here. Now when I run this program, what I get a square of all 3 inputs, right? Let's try and run this. So I'm getting a square of obj1 as in 9, square of obj2 as in 16, and square of obj3 as 25. Now let's say tomorrow my requirement is changing, and obj1 is having a requirement of getting the square of whatever the value I am passing. obj2 is having getting the square root, not square. So I am looking for a square root. obj3 is having a requirement of getting the cube or cube root, anything, right? And similarly, I am having other objects also, which is having different requirement, right? So with the help of this method, I cannot access that, right? So this method is actually calculating the square. Now to achieve that, I will have to write 3 methods, right? So let's say I am writing tomorrow public void again calculate, and then I can since it would be a kind of overloading, so I can let's say here I am passing int I, okay, and then I am doing like CISO the square root of is equal to maths dot sq, so it takes the value in double, so we will have to pass double only, okay, and let me take int here, okay, and here it is taking void calculate. Let's say here I am taking short p, see, so, and then the cube of I is plus x multiply x multiply x, okay. Likewise I am doing, so what it is saying, you have to take p multiply p, okay. Now what I am doing, I am calling these methods. Now what is happening here, these 3 methods which I created earlier will be accessible by all the objects, okay. So you can see here I can access calculate, which is taking the double as input. I can access calculate, which is taking int as an input, and I can access calculate, which is taking short as input, right? But I don't need that. I just need obj1 should calculate the square. I just need obj2 should calculate the square root, and obj3 should calculate the cube. So for that, what I will do, I will have this calculate method as abstract method here, and then I will implement that method in my subclasses. So if I do that, so what I will do, I will create this as abstract class. So abstract should come here, and in abstract class, what I am doing, let me create other 3 classes also. Let's say sub1, sub2, sub3, and then finally I am having one more class which will call these methods. So that class, let's say, having apps demo, which is having main method. Okay, so this is my abstract class, and in this class I am having this as abstract method. Okay, and then this subclass will, what it will do, it will extend or it will implement this abstract class?
Extend.
Extend, yeah.
Extend demo. Okay, now when you write like this, then it will say, please implement the abstract methods of this abstract class. So I will have to click on add unimplemented method. Then you will get this automatically. And here you can implement this. How can I implement that? Just copy this. And that's all. So let's change it to double, because this is more of a double input. Then here also, let's change it to double. So, and in subclass 2 also, I am extending demo. And in subclass 3 also, I am extending demo. So here also it is saying, please implement the abstract method. Here also it is saying, please implement the abstract methods. So in this method, what I will do, I will calculate the square root. So square root. And in this method, what I will do, I will calculate the cube. And I will remove these 2 methods from here. And then I will remove this also from here, because I will have that here. Okay, so now what error it is giving? It is saying do not specify a body. Okay. Okay, so this is my demo class, which is an abstract class. And in this class, I am having one abstract method. So to make a class, we use abstract keyword, and to make a method abstract, we use abstract keyword here. Okay, and I am having 3 subclasses for this demo class, abstract class. And when I extend this class, I will have to implement those abstract methods here. So I have a calculate class as abstract here, so I am implementing that, and I am calculating the square of x. In sub2, I am calculating the square root of x, and then I am calculating the cube of x. Okay, now if you see this carefully, I am having each subclass which is performing different tasks now. It is not like I am having all the tasks in a single class, right? Now to use that, I am creating the object. Now you cannot create the object of abstract class because we have an incomplete methods here. So whichever the class is having the incomplete method, You cannot create object of that class. So same is applicable for interfaces also. But you can create the object of the implementing class. So I can create the object of sub1 here. Sub1 here. And I can create the object of sub2 here. And I can create the object of sub3 here, right? So what I'm doing, I'm creating the object of subclass 1, right? And which is pointing to the reference of what? Of this abstract class. Similarly, I am creating the object of subclass 2, which is pointing to the reference of this abstract class. And similarly for this subclass 3, I'm creating the object of subclass 3, which is pointing to the reference of demo class. Now with the help of obj1, I can access only method which is actually calculating the square. So here I can give 2, and with the help of obj2, I can access the method which is calculating the square root. And with the help of obj3, I am calculating the cube, let's say cube of this. And when I run this, see the square of 2 is 4, the square root of 4 is 2, and the cube of this is 27. So this is how we are getting benefited. And object 1 can only do the calculation of, can access the calculate method and do the get the square. This subclass 2 or obj2 can calculate the square root. Subclass 3 or obj3 can calculate the cube. Yeah. So we are hiding the other functionalities, right? We are not giving the other functionalities to this subclass 1. Similarly, we are not showing the other functionality to subclass 2, and likewise this, right? So this is how abstraction is useful in the real world. Making sense? And instead of creating, object reference of this abstract class, I can create the object reference of sub1 also. That is also fine. But why we use object reference of abstract class? There is a logic here. So this is also fine. We can create the object of subclass 1 and then the reference of subclass 1. Okay. So why it is preferred to use object of subclass 1 and reference of abstract class? Because with the help of this object reference, we can access only the methods available here. We cannot access the methods available here. So let's say I am having some other methods here. Public void, let's say add. And here I am writing like int I equal to 10, j equal to 20, so I plus j. So if I am creating the object reference of this, right, demo, then I won't be able to access add method with obj1. This is not accessible now. But if I create the object reference of subclass 1, I can access obj1 dot add. Making sense? So the programmer is not writing their own code here. So that is the reason we used to prefer creating the object reference of abstract class. The same applies for interfaces also. Understanding that, right? How the abstraction is achieved there and how it is useful.
Yes, Nitin.
Yes, Nitin.
So I have one doubt, Nitin.
Yeah.
In demo Java, in that class we can have a abstract methods also, right?
Yeah, we can have non-abstract method also.
Yeah.
Probably.
At that time, we'll be able to create object for this.
No, we cannot create. Since there is an abstract method in this class, we cannot create object of this. If you try creating object of this class, it will give you error here. The demo d equal to new demo. It is giving you error here. Cannot instantiate the type demo. Okay. So they do ask whether can you create the object of abstract class? No, we cannot create. But we can create the object of implementation class. So implementation class object we can create. But one more thing here, we can declare the constructor of abstract class. There is no issue with that. I can declare the constructor of abstract class. Constructor. And that constructor is called when you are creating the object of implementation class. So constructor will be called here 3 times. Yeah. So you can create constructor of abstract class, but you cannot create the object of abstract class. Disha, any question here?
I need to go through it once, and then it's a bit confusing for me.
Confusing? What confusion you are having?
I mean, not confusing, but I need to have a hands-on for abstract classes.
Okay, fine. All right.
Then only I'll understand. Yeah.
Okay. So we covered abstraction, and then how it is achieved, why it is required, right? We covered abstract method, concrete method, and then we'll start. Yeah. Please.
Within one doubt, I'm sorry. Can you tell me how the constructor one was? When we are calling a method from subclass 1, right? Calculate.
No,
so
method.
Constructor also is called 3 times.
Yeah, constructor is there in abstract class, right? So eventually you are implementing this in subclass. So one copy of this is available with this also. Yeah. So whenever you are creating the object of child class, right? So the base class constructor is called, right? We have seen yesterday. Remember when we created two constructor, base class and child class, and when we created object of child class, the base class constructor was called automatically. Yeah, so same thing is happening here. So constructor can be called. You can declare the constructor, and that will be called at the time of object creation. Instead of this, if I write demo here, then also the constructor will be called. So constructor is called. All right, so we are pretty done here with abstract classes and abstract methods. Now we will talk about interfaces.